Hello, everybody. So we're going to work with lesson 1.6 on page 33 of the second grade Go Math textbook. And our topic today is different names for numbers. And our essential question is, how can you show the value of a number in different ways? So what I'd like you to start with is um, you'll have 26 one blocks. Okay, so count out 26 one blocks. Okay. And go ahead and put them in any arrangement. We just need to have 26 of them. I'm going to do groups of 5. Okay. All right. So again, there's 26, right? All right. So we have 26. So now what are the different ways I could show this? Well, right now that's 0 tens and 26 ones. Okay. It's kind of like the marble question in a couple lessons ago where they had 4 bags of 10 marbles and 6 singles. Well, in this case, we have all the marbles separated. There's 26 separate single marbles. Okay, so can we trade some of these ones for a 10? Well, we should, right? How many ones are in a 10? 10, right? That's why we call it a 10. So take 10 ones and trade it for a 10 rod. Okay, so now what do we have? We have 110, and we have how many ones? 10, 15, 16. So we have 16 ones. Doesn't want to focus right now. Okay. Could we trade another set of 10s? Well, I do have 10 ones, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 5, 10. So take 10 of those, take 10 ones, and trade it for another set, another 10 rod. Okay, so replace 10 ones with 1 10. So now how many 10s do I have? I have 2 10s. And how many ones do we have? We have 1, 2, 3, 4, 5, 6 ones. Okay. So these are all different names for the same thing. They're all equivalent or equal to each other. Okay. So 26 ones. Okay, so that's what we started with, 26 ones. And then we took one of the 10s, 10 ones, and traded it for a 10. And that left us a 10, and 16 ones. Then we took that second set of 10 and traded it for another 10 rod. So that left it was 2 10s and 1, 2, 3, 4, 5, 6 ones. But all of these equal the same thing. Okay, and that makes sense because all we were doing when we traded 110 for 10 ones was we took a 10 or 10 rod and replaced it or took the 10 ones that we had 2, 4, 6, 7, 10. Okay, so these are equivalent. 110 is equal to 10 ones. So that's all we did. We just traded. Okay, All right, so let's look at page 34. All right, so here's some ways to show the number 32. So they have 3 10s and 2 1s. Okay. Then what happens if we take one of the 10s and trade it for 10 1s? The number's still 32, right? We just took one of the 10 rods. Now we only have 2 10s, but we have more 1s. We have 10 1s plus 2 more. That's 12 1s. Okay, so we took one of the 10s, traded it for 10 1s. All right, what if we then take another set of 10, another 10 rod, and trade it for another set of 10 1s? So now we have 5, 10, 15, 20, 22 1s. And we have 1 10. So all of these numbers, 10 plus 22, 20 plus 12, 30 plus 2, all equal 32. Could I have 0 and 32 ones? Yeah. We could take this last 10, trade it for 10 ones, and we'd have 32 ones and no 10s. All right, so the blocks show the numbers in different ways. Describe the block in 2 ways. All right, so what do we have here? We have the number 28 shown in a model. We have 1, 2 10s. Okay, these are 10 rods. So we have 2 of those. That's 20, right? How many ones? 1, 2, 3, 4, 5, 6, 7, 8. 8 ones. Okay, so what is 2 10s and 8 ones as an addition problem? Well, it would be 20 plus 8. Right. Then what if we take one of these 10 rods and trade it for 10 ones? Okay, so now we only have 1 10, but we have more ones. So we have 10 ones that we just added plus the other 8. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the 10 ones we traded with the 110 rod. And we already had 8. So 10, 11, 12, 13, 14, 15, 16, 17, 18 ones. Okay, what happened? We traded one of the 10s for 10 ones. Now that's why we have 18 ones. So this one is now 10 plus 18. All right, what happens if we trade this last set of 10 for another set of 10 ones? Well, now we have no 10s, which means we have to have 28 ones. So 0 plus 28. Right? How about the number 35? Well, we can represent it with 3 10 rods and 5 ones. 1, 2, 3, 4, 5. So 3 10s, 5 ones. That's 35. All right. Now, what if we take one of the 10s and trade it for 10 ones? Well, that would be 10 here, right? 10 ones plus the 5. So 10, 11, 12, 13, 14, 15. And that's what we see here. 5, 10, 15. So 15 ones and 2 10s is the same as 3 10s and 5 ones. 20 plus 15. So in 20, how many 10s are there? There's 2 10s, right? In 15, how many 10s are there? There's 1 10. So 2 10s and 1 10 is 3 10s and 5 ones. Same as this one. All right, then what happens if we trade our other 2 rods? Well, each one of these has 10 ones, so 10 plus 10 is 20. So now we have 0 10s and 35 ones. Okay. And that math problem would be 0 plus 35. All right, let's look at page 35. 43. So we have 43 represented 3 different ways. The first one has 4 tens, 3 ones. The 4 tens, 10, 20, 30, 40. So 4 tens is 40. And then there's an extra 3 ones. So 40 plus 3. What's the difference between this one and this one? Well, here I only have 2 tens. So that means they replaced 2 of these tens with ones. There's 10 ones in every 10, so 10, 20. They added 20 more ones. So now we have 23 ones. And 20 plus 23 is 43. How did I get 20? Well, 2 tens is 20. How did I get 23? 23 ones. Okay. Or if this is like where you're starting, what if we only traded one of the tens from what we started with? If we started with 4 tens and 3 ones, what if we trade one of the tens for 10 ones? Well, now we'd have 10, 11, 12, 13 ones. So we'd have 30 plus 13. Okay, we could also go further. We could trade all of them except for one, and we'd have 110 and 33 ones. Or we could have 0 tens and 43 ones. Okay. All right, how about 30? How can we show 30? Well, we could start with just 30 ones, and then we could start trading them, right? Well, how many tens are in 30 ones? 10, 20, 30. There's going to be 3 tens in 30. Okay, so if we take a group of 10, that's 10. We can trade it for one set of 10. Take another set of 10. Okay, 10 ones, trade it for a 10 rod. Take 10 ones and trade it for a 10. So how many tens do we have? 1, 2, 3. 3 tens, 0 ones. What if we only replaced 20 of the ones? So let's say we replace these 2 sets of 10. Okay, we'd have 2 tens and 10 ones. Okay, can you think of one other way we could have done this? We have 0 tens, 3 tens, 2 tens. We could also have 1 10, right? 1 10. And we'd have 20 ones. 20 plus 10 is 30. So this one would be 10 plus 20. All right, number 5. I have 2 bags of 10 oranges. All right. So that's 2 bags of 10. And I also have 24 single oranges. All right, so make the 2 bags of 10, and now we're going to make 24 singles. You can do circles. I'm not quite sure why I'm doing squares. It takes more time to do squares. 5, 10, 15, 20, 24. All right. So the question is, how many oranges do I have? I had 24 single oranges, and I had 2 bags of 10. So 2 bags of 10 is 2 tens. And right now we have 5, 10, 15, 20, 24 ones. All right. Well, let's take 10 of the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And trade that for another 10. Now how many 10s do I have? I have 1, 2, 3. 3 10s. And how many 1s? I have 5, 10, 11, 12, 13, 14. Okay, could I trade another set of 10 1s? Yeah, there's 10 1s here. So I could take those 10 1s and trade them for one more 10. Now how many 10s do we have? We have 1, 2, 3, 4 10s and 4 1s. Okay, well, what's 4 10s plus 4 1s? 44. Again, so this little box around the 10 1s is being traded for 1 10. This set of 10 is being traded for a 10. 10 1s for 1 10. And the 4 1s, we can't trade those. We got to leave them as 4 1s. All right, so let's look at page 36. Fill in the blanks to make each sentence true. All right, so there's multiple answers for number 6. Okay, so basically I just need some number of 10s plus some 1s to give me 93. Well, the easiest one would be 9 10s, 3 1s. Okay, so 9 10s and 3 1s would be 93. What if I took one of the 10s and traded for 10 1s? That would also be an answer, right? What if I took 2 of the 10s that we started with? Well, then I would have 23 1s. I could have 6 10s. And then I'd have 33 1s. Okay, and you might start to notice a pattern here. 13, 23, 33. So 5 10s. So we're trading 4 10s, right? We started with 9 10s, and now we have 5 10s. So we'd have to give 40 1s if we trade. And we can keep going. Okay, we could have 4 10s and 53 1s. We could have 3 10s and 63 1s. We could have 2 10s and 73 1s. 1 10 and 83 1s, or no 10s and 93 1s. So technically, all of these answers could go here. Any one of these would work because they all add up to 93. All right, how about 2 10s and 18 1s? 2 10s, 18 1s. All right, well, 2 10s, 18 1s. Well, why don't I just take 10 of the 1s and trade it for a 10? Now I have 3 10s, which is 30, and I have 2, 4, 5, 6, 7, 8 1s. So 2 10s and 18 1s is the same as saying 30 plus 8. Or you could have said 20 plus 8. We could have also said 20 plus 18. We could have also said 10 plus 28. Or 0 plus 38. 5 10s and some number of 1s is the same as some number plus 17. All right, so 5 10s and some number equals some number plus 17. Well, that means we have 7 1s, right? Look here, we have 1 10 and 7 1s. 1 10. Here we have 5 10s. So how many 10s would you have to add to the 1 10 to get 5 10s? It would be 4 10s, right? 4 10s plus 1 10 is 5 10s. So 4 10s is 40. So 40 plus 17 is the same as 5 tens and 7 ones. Okay, number 7. A number has the digit 4 in the ones place. Okay, so I'm just going to draw our little place value chart since we're dealing with tens and ones. All right, so we have a 4 in the ones place and the digit 7 in the tens place. Okay. So this one's not right because that's backwards. It wasn't 4 tens. 4 plus 7, those are ones, right? 4 ones plus 7 ones. Well, that's not equal to 7 tens. So it can't be that one. 4 tens and 34 ones. 4 tens and 3 more tens, right? There's 3 tens and 4 ones in this number, right? So 4 tens and 3 more tens. 4, 5, 6, 7. So this is 7 tens and 4 ones, right? If we just look at the 3 tens and the 4 tens, that gives us 7 tens. So this is a possibility. 40 and 7 more. That's 47, not 74. This one's 74. 70 and 4 more, right? And this one says 74. Okay. All right, number 8. Which of these is another way to show the number 42? Choose yes or no for each. 110 and 42 ones. 110 and 42 ones. All right. So 110 and 42 ones. Well, if I have 42 ones, that's already 42. How can I have an extra 10 ones? Right? Because here, that's one set of 10, 2 sets, 3 sets, 4 sets of 10 right there. Right? So 4 sets of 10 plus the 110 we already had, that's 5 tens and 2 ones. That's 52. No. 30 and 12. Well, 30 is 3 tens and 0 ones. 12 is 1 10 and 2 ones. Well, how much is 3 tens and 1 10? That's 4 tens and 2 ones. 4 tens is 40 plus 2 more is 42. That works. 2 tens and 22 ones. Let's see. 2 tens and 22 ones. Can we rewrite 22 ones? Yeah. 22 ones is the same as 2 tens and 2 ones. Okay. So we could change the 22 ones into 2 tens and 2 ones. 10, 20 plus 2 more is 22. So we have 4 tens and 2 ones, 42. 3 tens and 2 ones. Well, 3 tens is 30. 30 plus 2. No, that's not 42, right? That's only 32. So no. All right. So that was the last one for today. So until the next time, I will see you soon.